My name is Yelena Kuchina. I am the instructor of this quick course, 6 weeks course. Let me talk about what this course is all about. So it's not a simple physics course. It's more like boot camp for physics inclined students, right? F equals MA is an exam that is taken nationally, and it does not cost as much as a P exam, but the consequences are much fancier, I would say. So if you pass this exam with flying colors, you will be invited into physics Olympic team, which is an honor, even if your team will not perform the top. Being there is an honor, right? So let me say a few words about me. My name is Yelena Kuchina, and I have 2 PhDs in physics, and something should tell you that I love physics a lot, right? One of these degrees is in physical and mathematical sciences, and that's the degree received from former Soviet Union Republic, Kazakh Republic, and Kazakh State University. In normal language, it means that it's a degree in theoretical physics. So I love math and I love physics, and the baby of these two disciplines is theoretical physics, and I have PhD in that. And then I moved to Old Dominion University in Virginia in the United States of America, and I got another degree in pure physics. And not only it was in theoretical physics, it ended up in postdoc period where I was participating in experiment based on my theoretical predictions. So I made the predictions first, and then I was lucky enough to do the experiment with a team of extremely smart and dedicated people to see if the theory is right or wrong. So unique experience, truly unique experience. About 20 years ago, though, my third child was born, and I decided that I'm not anymore competitive in the field of physics, and I should find a different career for myself. And I'm happy that I looked into education, because now that I stayed for almost 20 years in education, I cannot imagine what else can I do? It's fascinating to work with students and see how similar they are and how different each of them are, how differently they think, how differently they show their care about physics or dislike of physics as well, and seeing them grow as we learn physics and they practice physics is a very nice experience, and I enjoy it very much. So I have experience in research, in education, and once I started education, not at once, but for about last 10 years, I was preparing students for F equals MA on a yearly basis. We would study physics, we will practice problem solving in a format that is similar to F equals MA exam. Just like you can take a physics and then go and take AP Physics 1 exam, would work. But if you take AP Physics 1 course, it will train you to a language, to a dialect that AP Physics 1 writers have, and you will be more familiar with this particular exam. So the same way we will be working on the problems and examples from the exam itself, train ourselves to answer questions quickly. And for that, we need to solve many problems. Typically, the cutoff score on the test is relatively high. So you have 25 questions, 75 minutes for a proctored exam. Easy calculation shows you that you will need 3 minutes per questions, but the level of questions is different. Some are very easy, something that even the beginner student in physics can answer, and you will necessarily have 2 or 3 questions like that in your exam. And then there will be a diversity of questions that will be harder. And I will show you some examples that for you to have a feeling of what it could be. All the questions in this exam cover mechanics only. So there is no electricity, no modern physics. Sometimes there is a question that kind of just test if you have a feeling for that, some random questions in quantum mechanics or something. But truly, all the questions do not require you even to have calculus knowledge. So if you covered AP Physics 1, you should be well prepared for this camp. Simple physics, maybe not rigorous enough, but it depends on the student and the teacher and the course itself. So I wouldn't exclude them. If you know basic fundamental laws of physics and you can do basic algebra operations, you're good to go into this camp. The benefits of taking this camp during the summer is that you're not distracted by the other schoolwork. So you can really, really devote yourself to preparing for this exam. You can do this later on in the winter to refresh your knowledge with new problems and new ideas of how to make it work for the students. And we will try to solve any problems. The idea is to bring you to the state where you can, by reading the question, you can immediately come up with the ideas of what is relevant in here, what we should apply in here, and answering question not in 3 minutes, but below 3 minutes, because our good score is 15 and above, right? And again, the easy one, the one that is momentarily solved, is maybe 3, hopefully 4 questions. After that, you will have to think. And thinking takes time. So the more complicated the problem, the more time it will require. So at least the simple questions should be automatically coming out. And how do you achieve that? You achieve that by practicing a lot, by solving problems from these exams over and over again. And we have a collection of these problems available on AAPT site, problems and solutions. Some years have solutions separately from problems. Some would have them incorporated, problem and solution in the same document, but it's available there. And there is also USA Physics Olympiad materials, previous tests and problems and their solutions. So you can look at this and solve. The more problems you solve, the better. The benefits of having me as your instructor of this course is that you can master everything that I supply, but you can bring your problems in and ask these questions so we can solve it together. So having an expert to answer your question could save you time, could teach you how to approach a new problem if a person never heard of it before. So that's one of the benefits of taking this class and trying to challenge yourself with physics problems. You see that in pre-COVID exams, 2018 and 2019, there were two exams, exam A and exam B, and it didn't stand for long. They tried to have two different exams on different dates because of different school year events running on the same day. So they would offer 2 days of exam, and they will have different exams on these days. So the idea was to create two very close by, by the topics, by the concepts covered, to close exams. And it's an easy to think about that, but it's very hard to create such a test. So currently we have 1 day, and during this day, students take in 75-minute quiet time and solve 25 questions. It typically takes 90 minutes, and 15 minutes goes into filling out your name and all this information and reading the what's allowed and what's not allowed on the test. So it's more 15 minutes of prep time, not really some time that you can use for problem solving. In the past year, in this year 2025, and each exam is about early in February, date changes. They post the information early in January to set the date. And as you see here is that some students haven't solved any single problem, and some solved all 25. That's a diversity of students who typically take the test. At the same time, the number of test takers, you see, a submitted test was less than 6,000. So very few students are selecting this test. So if you're well prepared, that's a low risk, I would say, test taken, just because competitiveness pool is not as wide as, for example, for AP Physics 1. But at the same time, it's not to get a certain grade, it's really to solve more problems. And you see different statistical figures in here. I hope you know what they mean, what median means, what mean means, and what standard deviation means, right? It's statistical measures. If you're interested, we will go into that as we go into measurements and statistical error analysis. That will be part of this course. So for taking this exam, you should be either U.S. citizen or U.S. Permanent resident, so legal citizen of United States of America, or currently attending a U.S. school. You can take the F equals MA, being just attendee at U.S. school. I believe to get in onto Olympic team, the regulations and selectiveness is a little bit higher, but showing that you're smart enough to get there, I'm sure you will get a help to get your permanent residence or something. At least I wish you, if you're in this position. So what is allowed on this exam? typically on the AP exams, you're given a formula list. For the F equals MA exam, there is no formulas. So one of the things that we will do initially, but we will take away one formula after another, is formula list. I urge you to have it at your side for at least the first half of the course, because by looking at them, you will be memorizing them. You will notice that at certain point you won't need it because you've seen it so many times you remember it by heart. But having it in one space, in one place, next to your working area is a tremendous benefit. First of all, the formula list, if it's organized correctly, it will go by topics. So as you realize what kind of concept is applicable to this problem, you can look at the scope of formulas available to you and select one instead of going from the top through the list of 100 formulas to find what will be a good fit. Currently in AP exams, they have a link, and then this link goes to a series of links by topic. If you group it on one page, and if you're using it day after day, you will have enough exposure to this formula that on the day of tryout or on the day of the exam, you won't need this. You will remember this, just like you remember your name, I hope. So if you pass this F equals MA exam, and typically they select from 400 to 500 students, and that's what creates this cut off. They look at, how many students will get into this 400 group. You will get additional training for the USA physics team, and you will be trained face-to-face, on-site, and that will be very, very strong competition, and you will see many smart kids in there. Just hanging with them will be pretty interesting. All the questions on the exam are free response questions. Most of them have 5 possible answers to reduce the probability of you just guessing the answer. And while they say calculus-based exam, typically calculus is not what's required, Most of the time, it's logical thinking, algebra skills is everything that you need. Topics include mechanics. I haven't seen electricity and magnetism for years, so while it could be electricity, magnetism, nuclear or atomic physics, it could be one question among 25 that will be out of the world. Typically it's mechanics only, heavily on first chapters of physics, and then as we go deeper and deeper into more rigorous concept, the level of questions will go up, the easiness of the questions will go up, but it will be less frequent appearance on the test. Okay. And actually, that's F equals MA. For physics Olympiad, that's where electricity and magnetism and atomic physics will be part of it. So preparing for that will require you an extra training. And you see that the exam itself will have more time involved and different rigors. level of rigor. And you see that the top finishers are invited into US physics team. You can read it all on AAPT website, and AAPT stands for American Association of Physics Teachers, and you just ask for physics team, AAPT, and they will give you plenty of information. The information covered in F equals MA, you see it's totally mechanics, and we will cover all these topics. But that's only physics concept that will be included in the exam. I've seen, on top of that, I've seen waves and periodic motion in there. So I will try to introduce you to as many problems as possible, and we will solve it every class. So a quick review of the topic, and then we will start from easy questions to harder questions. Then we will take a quick break, and then we will practice problem solving individually and checking how many questions we answered correctly. Now, don't be discouraged if you didn't answer all the questions correctly during the class. That's not the point, not at least at the very beginning. The point is to learn how to train yourself to think for the exam, how to train your brain to focus on physics concept so you can pull them out as quickly as possible and put them and interweave together and apply to the problem solving. Here's one of the questions that has been on one of the exams. See, it's problem number 1. You expect it to be a simple one. And some of you who took AP Physics 1 or AP Physics C Mechanics or honor physics would immediately recognize 2 ways of solving this problem. Unless you remember the solution, because that's a kind of very traditional problem to begin with. So when I will show you the problem, I will ask the students and I will say what concepts are relevant in here. Which way should we solve this? And there are 2 ways in this case to solve it. You can use energy conservation or you can use kinematics or free fall, because the projectile is straight up, and we can think about how the projectile goes up, draw a picture, write formulas, and draw our logic from here. But again, this problem is one of the easiest ones, and you should expect yourself to answer it in 30 seconds or less. That's the end of the training, not at the beginning of the training, okay? So if you cannot answer it right away, take some time. I can tell you the correct answer, but it wouldn't help, right? So maybe, just maybe, take a snapshot of this, and the video is available one way or another. Try and solve it for yourself, and we can discuss it in the first class if you're interested. One of the questions that students sometimes find very difficult, especially with very formalized learning of physics, is reading the problem and predicting the outcome. And here you see 5 different trajectories of the what ball that will be falling, and you have to select one of these 5s. You know, no argumentation is needed on the exam, But if you select it during this class, you will have to explain why you think so, you know. Um, what you need to answer this question is simple kinematics, right? Projectile motion or things like that. And again, question number 5, you do not expect it to be very hard, but it could be hard just because no math is involved, no symbols or anything. You need to feel the physics in here. Oh, one complexity comes from joining several ideas. So in this question, uh, just a few words, right? But you see a coordinate system with two particles of the same mass moving in opposite direction in you know, not in the same place, but somewhere close by. And the question asks, what could be the later on snapshot in case no external forces are acting, so only internal forces. And the way to solve this problem, and again, I will let students to think for a minute or two of what could be the available or applicable concepts in physics in here. But then we will have to exclude wrong possibilities. And again, in this case, not enough information. It's not a standard problem for us to solve. It's unusual problem, and that's the main difficulty. Once you figure out how to solve it, it's an easy question altogether. But it's unusual, and unusual is difficult by itself. So in this case, you have masses, you have velocities. Something should tell you if there are only internal forces, momentum should be conserved. So you look for conservation of momentum. Well, because it's the same system of two particles, and as you see on the initial snapshot, the total momentum is 0. You should expect the total momentum in X and Y direction to be 0 as well, right? And that will exclude, for example, case B, right? But I have 4 other cases. What am I missing? I have conservation of momentum for all the other cases. What other law I am missing that could involve velocity and mass and momentum? Well, because your momentum is 0, it should stay 0 for the duration of the process in absence of external forces, which means your center of mass should stay in the same place. It shouldn't move. For that reason, case A is excluded, because you see the center of mass for these particles in case A has shifted. That's impossible. So we have, we are left with what, 3 leftovers, I would say, right? So what can we say about the other cases? What else could be conserved that we need to think of? So you see, it's not trivial. You have to think of what else could be applicable in here. And if you involve also your conservation of angular momentum, which is not obvious at all. So you need to come up with this idea. You will find the correct answer, right? So I will leave it to you. Which one is the correct answer? You have only 3 options to select from, and we can discuss it in our first class. And finally, question number 25. It sounds very simple, but the solution is not that simple. So it's about a cylinder that is placed with its axis vertical, and rubber band of mass m and tension T is wrapped horizontally around it. And they ask, what is the minimum coefficient of static friction between the rubber band and the cylinder such that the band will not slide down the cylinder? And again, that's not a traditional physics problem, right? We typically talk about friction when surface and majorly gravity is pushing against the surface, so we know where the normal force is coming from, not when it's a rubber band around the cylinder. So in here, a much deeper thinking in physics is required. Elasticity of the rubber band will be important. How dimensions of the rubber band is changing as we stretch it. How the tension is changing the direction as the band is wrapped around the cylinder. That's a very rich problem, and we will have to solve a few of them every day, every session, just because we need to learn how to put things together and how to pull the knowledge that was not formally placed in a formula sheet for us. How do we get a feeling? We don't need to put a solution. We just need to find the idea of what could be important in here, okay? Additional materials that you may need. Any textbook that you've used for your previous physics class would be helpful. In here you see 3 textbooks. Um, one is Resnick official textbook. Another one is Young textbook. I love Young just because it's very deep, and if you have an engineer in mind, it covers wide selection of topics in physics and introductory physics, and then it gives deep enough for you to get to know physics well. And supplementary book in here is listed as Intro to Classical Mechanics. It's a small book, paper book by David Morin. He has several textbooks, and one of them is Problems and Solutions in Introductory Mechanics, something like that. You can look it up on Amazon. And it has a special chapter devoted to F equals ma. And it covers many topics that will be relevant to FMA training. We will meet twice a week for 2 hours. In between, you will be solving homework. If you've been to AP Physics 1 in Momentum Learning, you already know what's expected. There is a lecture, we're discussing it, we're practicing, we're learning, and then you have to do homework. In this case, for F equals ma bootcamp, you need to solve, I don't know, 10 problems for each problem that we solved in the classroom. And if you're done with your homework, don't stop there. If you have time, solve more. If that's your idea of fun in the summer, please enjoy it, because there are plenty of resources available on the website. So once you register for the course, students will get the link to the Zoom, and once you link to the Canvas and once you enter your Canvas site, you will see something like that, the same blue screen, I would say, with middle section link to join the Zoom session that is scheduled, as we said, every Thursday and Sunday from 6 to 8 p.m. So again, if you prepare to start the class, you should have your plenty of paper, plenty of writing utensils, and plenty of water, and formula list of your choice, the one that you like. We can come up with something better. I can share what I have for my students. It's a little bit lengthy, but we can just decide what's needed, what not, and make our own version pretty quickly. But again, the idea is by the end of this camp not to use it at all. It's just like a helping hand for us to move quicker through this boot camp, because boot camp is do and try your best, right? Now, one of the things that is important, as much as it is important to know your physics and know your math and do as few mistakes as possible, it is also important to pay attention to your mistakes. So mistakes are there for a reason. And the reason is the missed knowledge or missed attention or lack of focus. The reasons could be multiple, but we need to identify these reasons for us to work on this in the future. So please be mindful about, your mistakes, your type of mistakes, and you can do that by analyzing your wrong answers. What did you forget? How would you know that that was important in this problem? This thinking typically takes time right after the class and takes a lot of time. So, take your time, ask your questions. It is a good exercise always to come up with a different solution. So even if you answered all the questions correctly, don't stop there, try and come up with different solution. Always have your focus on how else can this problem be solved? What else am I missing? So it will be in a little bit more than a month. We start on July 10th, and we end in August, and we will be solving problems all the time. So please be prepared to spend time with physics. As you see, prerequisites AP Physics 1. If you're not familiar with Momentum Learning organizing of the course, again, once you log into your Canvas, you have your link to join the class, your Zoom session right in front of you. You cannot miss it. It's right in the center. So that's, last minute, you forgot about physics, put your alarm clock, but better be prepared before that. Join the Zoom session and be active participant in the session. Ask your questions, give your answers, explain your answers. Be ready to actively defend your point of view. If you're just sitting there by yourself with a dark screen, you won't be able to learn much. You have to be active to participate. So please expect for me to call your name and ask you a question. It's okay if you answer incorrectly. It still starts the communication, and we can polish whatever we haven't learned yet all together. Okay, so once the first class is over, first Zoom session is over, you will be finding all the materials in under this button, class 1. If you remember which class we just had, you will be able to find your information on a particular class in here, in these 12 buttons. If that is not, if you forgot which class it was, you can always click on modules and you will see handouts, homework, and recordings posted for the sessions, for the past sessions. So you can go and rewatch the class if you're interested. Oops, sorry. Yeah. Or you can work on your homework, which is very, very necessary. Don't skip any homework. Yes, it's not a grade that will go into your transcript, but that's the only way to learn how to solve this problem, by doing it independently. Doing it in group is good experience, but doing it by yourself is what it takes. And don't use any help, because internet help. Don't do that. Try your best. Let's work together, but don't try to find a quick solution. It saves time, but it cuts off opportunities for you to learn. Okay. You will have access to all these handouts for an extra 3 months after end of the class. And you will get the link to this Canvas about a week or a little bit earlier, before the first day, which is July 10th. So about July 4th, you should get your link to this Canvas. Okay, now something else that came and went right away. Cannot remember right now. Topics that will be covered. I want to mention, and I mentioned it a little bit earlier, that I've seen waves on these exams. So looking through the past exams should help you tremendously. But at the same time, you see that the topics of these classes are pretty much the same topics that are in a regular physics course. We just won't spend as much time lecturing about that. We will go over the most important stuff and we push to problem solving. So call it recitation for session, call it exam, but we will be present for solving more problems. Because we have plenty of problems in a one-dimensional motion in our bank of questions and not that many in oscillations of fluids, please expect that as we go from class 1 to class 2, we will eventually review, in class 2, we will review a little bit of class 1. In class 3, the first 2 classes. So we will be always adding some problems from the previous chapters. So you will keep your sharp knowledge of these chapters as much as possible. On top of these classes, I don't see it mentioned in here, but we will have also dimensional analysis and statistical analysis uh, of experimental results. So that is something that is also part of the F equals MA exam, and we will cover this as well. So typically, these particular topics are not covered in the textbook. So that's where you would expect a more of a lecture and just a few questions that, will give you a good feeling of how your question could sound. But that will be, again, incorporated into this class schedule. Final tips. We will cover every topic. I know that rotational motion sometimes goes so far towards the end of the school year that students never get a grasp of it. But rotational motion is typically, you've been to motion, kinematics, you don't need to spend another hour or two on another type of kinematics. You do. And we will spend time on that as well, because that's one of the most difficult topics in an introductory mechanics. So we have to absolutely be flawless in rotational motion, both kinematics and dynamics. Calculators are not allowed. If you saw the questions, you saw that numbers are not given, right? One kilogram, 1 meter per second. It's not something that will require a calculator, right? Everything else you can count to 1 to 2 is possible. So calculators, graphing calculators especially, not part of this exam. So don't put them there. Don't make the use of them. And always make sure that you know the whole thing of the whole problem statement, that you read it carefully. And please read all the answers. Don't go to the first answer that sounds like a correct one without checking the other options, because that's one of the typical mistakes that students do. They save on time. Yes, they do, but sometimes two answers are correct, and at the very end you will have this option, but you will not know that this option existed unless you read all the answers. So reading quickly is one of the great skills to have. And especially nowadays when people are reading not enough, I would say. Time management is very important. So accuracy is just, and time management is all about organization of your thinking and your writing. My experience as an instructor shows that if students is fully cognitive of this topic, knows what he's doing, the work is well organized and easy to read. If I see a spot here, spot there, started problem a different way, that means student is lost, and not necessarily I can find the correct solution. So practicing it several times could help you truly to discipline your writing, to discipline your brain work, so it will be quicker response from your brain. Again, if you haven't experienced it yet, if your workspace is well organized, it will take you less time to get to the result. So the same way in physics, if you have everything organized in your brain, if you know how all the topics are related, and that's one thing that we will quickly cover in our lectures, what will be relevant for this topic from previous chapters, from previous knowledge. That's what we will be looking at, and time management, ticking clocks is very important. That's why we will have these sessions of quick problem solving with screen changing every 3 minutes, which is not fair because some problems require more time than the other. But that's what we will be doing just to practice the time regime, okay? Group study. You have your opportunity to collaborate in the course and communicate with each other. Group study is very helpful and very healthy when you prepare for the class, when you're doing homework. I know that currently we are more inclined to ask artificial intelligence or Google search engine, which is also artificial intelligence. But talking to your classmates, to your peers is much better thing, because that's your peer talking. Their experience is very important and very similar to yours. It will be different from mine experiences. So talking to your peer will help you to better capture what you're missing, because your brain should be always analyzing what I'm doing good, what am I doing not as good as I wish. And so always be very critical about yourself. And practice, 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 practice. This time it will be really boot camp. It will be too much practice, but probably not enough. The other session in the winter will be more close to the exam, and you're more than welcome to take it again and show how brilliant you became by practicing problem solving. But truly, there are plenty of problems to solve, and you hardly have enough time to devote to these problems. My job will be selecting these problems so you can have a diversity of different problems, different in complexity, different in strategic approach, different in applications, and things like that. And if you have any questions, here's the phone, email address, and office hours of the main office headquarters in Momentum Learning. Do you have any questions? Okay. If you miss a class, the video will be posted. Very good question, by the way. I forgot to mention it. Every class is recorded, and it is posted on the Canvas next day, next morning. So once the session is held, for example, today's session open house is held, tomorrow morning it will be posted and be available for you to watch over. So the same way will videos for the classes work. So if you miss a class, which I don't advise because you will have to watch it one way or another, right? You will have to participate it one way or another. But if you're watching it, without ability to interact, which is I like when students are bouncing off ideas of each other and trying to resolve it. If you ever had experience in regular physics class, typically they first show you the strategy and then they will give you a bunch of problems to use this strategy so you know how to approach the problem. That's not the true statement about F equals ma. You won't have a strategy for most of the problems. You will have to create this strategy. So variety of problems would be required. And yes, you watch video if you missed the class, but try to make it to class, okay? How many problems per each assignment? Um, Honestly, I don't remember the number. But I hope that, that we will have about 20 problems per session. I doubt that you will have 200 problems for your homework. It will be much less. But generally speaking, um, I would expect 20, 30, 40, and two homeworks per week. So it will be enough of homework, that's for sure. But allow yourself um, enough time. I think it's a very important thing, even if you do not plan to participate in F equals MA. It just it develops a different way of thinking in physics. If physics is something that you like to do, your mind is craving for different problems and finding the solution, right? Your good feelings come when you solve the hard problem. So that's where we will have our fun. That's, again, topic is known in advance. You will know what we will be talking about. Please prepare before the class. Please refresh your knowledge so it won't be uh, a big deal for you. And once we start our class, always ask your questions. In my class, we didn't cover this and this. Can you quickly tell us how this, explain us this concept or that concept if you still have questions? Okay, so be prepared before the class. Be very active during the class because that's where your brain will uh, work the most. Uh, be prepared to take a quick, I don't know, 10 problems in 30 minutes, right? And and then we will quickly go and check our solutions. So you will have your solutions for sure for each problem that we cover in the class. Typically for the class, I prepare problems only and do not prepare the solutions ahead of time. So we should be free to come up with any solution we find possible. But as I post my handouts, after the class, which I do after the class, the same evening. That's where I insert all the solutions. So in your handouts, you will have not only problem, but the solution to the problem as well. I hope to see you in this session. No, it's summertime, right? It could be more fun.